Today we're going to do operations with functions. So a lot of this is review really from the first day of school. So when I evaluate a function like f of 2, what it's asking me is if I were to input a 2, what would the output be? Or in other words, if the x coordinate of an ordered pair is 2, what's the y coordinate? 5. If I say f inverse of 9, it's saying if the y coordinate is 9, what's the x coordinate? 4. H of 5 here is showing me there is 24. H inverse of 3 is saying if the y is 3, the x is 2. And H of f of 2, well, f of 2 we said was 5, so H of 5 we said was 24. So a little composition of functions. The next questions I love, they're visual, right? Looking at the graph, if this graph is g, what is g of 1? In other words, when the x-coordinate is 1, what is the y-coordinate? Right, 1. What if the x-coordinate is negative 1? The y-coordinate is negative 2. If the x-coordinate is 3, the y-coordinate is 0. X-coordinate is negative 2. That doesn't look exactly like 0, but I'm going to make it 0. We didn't mean to make that hard. The domain is, if you swipe back and forth, where do the x-coordinates start and stop? Well, they start at negative 5 and they go through 3. Where do the y-coordinates? They start at 2 and they end at negative 3. Or sorry, positive 3. All right? This one's a little hard where we have two equations, an f and a g. The f is the pink one, the g is the blue one. So f of 0 on the pink one is saying, okay, when x is 0, y on the pink one is 3. G of 3 is the blue one, so when x is 3 on the g function, I'm at 4. G of f of 0, so we said that f of 0 was 3, so this is the same thing as g of 3, which we just figured out was 4. G of negative 2, if the x value is negative 2, that g value is 1, so then it wants me to evaluate g of 1, which is 1. F of negative 4, f of negative 4 looks like negative 2, and then f of negative 2 looks like 1. It asks where are the 2 points where the f of x is equal to the g of x. Those are the ordered pairs negative 2, 1, and it looks like 2, 2. So it just really reinforces that visual component of evaluating functions. For function operations, we're going to add or subtract functions. So f of x is x plus 2 from the directions, x plus 2. G of x is negative x plus 1. Oops, they're not equal to each other. Sorry, we're just adding those. X plus 2 plus negative x plus 1. So it's just 3, right? G of x, negative x plus 1 minus x f of x. Right? And we'd have to distribute. So negative x plus 1 minus x minus 2. What do I get? Negative 2x minus 1. F of x plus 3. Well, sure. X plus 2 plus 3. X plus 5. So nice, right? H of x is x squared over 2f of x. I'm going to distribute that. So 2x plus 4, and I'm done. If you wanted to leave it 2 times x plus 2, that's fine too. Piecewise functions, we did those at the start of the year, right? It depends what x value it is, which rule you use. So h of 5. 5 is bigger than 0, so I'm going to say 2 times 5 is 10. But negative 3 is less than or equal to 0. Negative 3 squared, positive 9. 0 is 0 squared, so 0. 3, of course, 2 times 3. Negative 2 would be 4, and h of 1 is 2 times 1, or 2. Visually, again, this is the f function. Now, usually I do something like a closed circle and an open circle to keep it a function. F of 2 looks like it's down here at negative 2. F of 0 would be where the closed circle was, so that's at 2. F of negative 1 is also at 2. And f of negative 2. So f of negative 2 is 2, and then f of 2 is negative 2. Kind of tricky. Reviewing piecewise functions from the first chapter where we're going to take a piece of each function. So the first one says negative 3, f of x is negative 3, but we're only going to take the piece where x is negative. So we're only going to take this piece of that line. So here, this piece of the horizontal line goes in our final answer. 2x plus 1, and I know it's hard to draw on here, is like basically this line, but we're only taking the piece where the x coordinates are greater than or equal to 0. So I'm going to start with a closed circle on 1, and then up 2 over 1, up 2 over 1. So we did that back in the first chapter. Now we've learned many more functions, right? So maybe we do a piecewise that's an upside down parabola where we take maybe just the piece where the x coordinates are negative, and then we add on to that an exponential function, but we only take the piece where the x coordinates are bigger than or equal to 0. So we would start there at 0, 1, there's the dot, and then there. So a little wrap up of a lot of different things all under the umbrella of function operations.